Okay, it seems like we lost the recording, so let's do this quickly from scratch. We are in the PureScript environment now on the right hand side, which is available in the repo as well. What we have here is a couple of commands that we can use to run PureScript projects, which is Spargo and PureScript itself and stuff like this. But we also have LBF, LBC, and LBG. We prepared a make file, so we don't have to reinvent the wheel here. The only thing that's different from the Haskell version is that we are invoking this command when generating code for PureScript. Instead of gen Haskell, we say gen PureScript. So let's go ahead and compile and go generate our citizen schema, which is on the left hand side. As we see, the compiler was successful and clone generation was successful. Let's inspect the autogen directory. As suspected, we have this, the files co-generated for us. We have these type definitions here and a bunch of implementations that we will verify that they work in a minute. So let's go into a PureScript shell, which will compile the entire project with the co-generated files themselves. So if this works, this can be considered a success. It's quite slow. Hello. Maybe I need to do something like this. I don't know why this is not working. Okay, no idea what happened. I just had to reload the shell and it seems to have worked. Well, now again it's taking time. What is happening? Okay, third time is the charm, I guess. We loaded the shell and all the files successfully compiled, which means we should have something under Lambda Buffers. Okay. Similar to what we've seen in Haskell, we have a bunch of modules, citizen being the one that we actually care about. Let's load it and let's try to build to citizen, Dražen, and then compare them for equality, and then write them into upload to data encoding. For the sake of time, I prepared a couple of imports that we will need and a small utility function. I think the screen recording is weighing very heavily on my computer, and that's why we are having these issues. I think. Let's see. This is very, very slow. Yep. I think my computer doesn't like the fact that I'm recording in high definition. Okay, let's do this quickly and save everybody's time. This is just a function that, given a string, creates a ledger bytes. And let's create the first object, which is Dražen. As we've seen before, well, yeah, we make a citizen, use a record syntax, we give it the first name, the last name, and the national ID, which is a Swiss visa type B. Right, so we did that. doing the same with Nanad. Yeah. Okay. Yes, it's not that. It's creation ID card. And now we do this. My apologies because my saved script wasn't up to date, it seems. So there's a bunch of errors I have to just account for. Okay, so we have Nenad and Dražen created. Let's compare them for equality. Is Dražen equal to Nenad? That should be false. Is Dražen equal to Dražen? That should be true. And is Nenad equals to Nenad? This is very, very slow. I think I have to cut this recording short to save my computer from dying. Okay, now let's see how Dražen encodes into Pluto's data. And let's see how Nenad encodes into Pluto's data. Great, this seems to match what we've seen in Haskell, so thumbs up. Thank you for your time and attention. I think this was very long. Sorry for the plethora of errors we had to deal with, but it's late and I'm very bad at recording interactive sessions.